We did it! We made it to the function section, or at least part 1 of functions. This is really the last of the great topics that we have left to cover with Python. There's a lot of material left to cover, but it's a lot more kind of nuanced pieces or more advanced things to talk about. But functions are pretty much the last important, essential building block to Python that we have yet to discuss. We've kind of seen them in the periphery. We've talked a little bit about them. We've been using tons of built-in functions, things like print and len and count and all those things. But now we're going to see how we define our own. And I'm personally really excited for this section and the next couple because we have a bunch of pre-written tests, interactive code exercises in the browser that have you write functions. So you'll be writing almost 30 functions if you do all of the exercises. You'll almost write 30 functions in a matter of 1 or 2 sections. So you'll get tons of practice, spend a lot of time on those tests because functions are so important. It's worth it. So let's get started. And the first thing to talk about are the key objectives for the section. So first, we want to describe what a function is and how they're useful. Be able to talk about the utility they provide. Then we want to discuss what the return keyword does, be able to write a function using it, and also talk about how side effects relate to the return keyword. Then we'll learn to add parameters to functions so we can accept input and then spit out output, different output depending on the input. After that, we want to talk about how to define and diagram scope. What is scope, and then how does it work and how does it relate to functions? Lastly, we'll learn to add keyword arguments to functions. But before we get there, we need to answer the simplest, most important question: what is a function? Well, we've been working with functions a whole bunch, like I already mentioned, things like print or len for length, but also all the built-in list methods or dictionary methods. Technically, they are called methods, but if you didn't watch the video where we talked about the distinction, methods are a special type of functions. So they're all functions. They're all built-in functions. So what do they have in common? Well, officially, a function is a process for executing a task, which I kind of think that's a bit stuffy. I just like to think of them as a bunch of lines of code wrapped up into a nice little package that we can recall at any point. It's like shrinking down a bunch of lines of code and making it reusable. But what's important is that we don't always get the exact same result every time we call a function. It depends on the input we provide, which can alter the output we get back. So it's like a little box, and not every function accepts an input, but some of them do, and when we provide an input, we get something out, something happens. So another way of thinking about them is they're just a useful way for executing similar procedures over and over. So it's not always identical. You can write functions that do the exact same thing every time, no matter what, but most of them that we'll be writing will do similar things, like add 2 numbers together, but the result depends on the numbers that we provide. So here I have a simple list called colors, and we've seen so many different built-in functions. Something like print, that's a built-in function. I pass in colors, and it prints out colors, or I pass in a string, and it prints something, but this time we get a different result. Likewise, we could do color.append, which is another function, and I pass in violet. It takes that input and adds it to the end of colors. So it does a process, and it's repeatable. But there's also functions like clear that we've seen, which don't require any input. They do the exact same thing every time. And if we look at colors, it's totally empty. So clear will always do that. It doesn't matter if we provide an input or not. In this section, we'll see how to write both types of functions, ones that accept input and ones that don't. So why do we care about functions? Why use them? The first reason is that it helps our code stay dry, which is an acronym that a lot of teachers like myself rely a bit too heavily on when teaching functions, but it's easy to remember. Dry stands for don't repeat yourself. So it's a way of keeping our code clean and not repeating ourselves. The opposite is wet, writes everything twice, W-E-T. So we want to keep our code dry, and functions help us do that. Because let's say we had a task that took 10 lines of code to do. If we wanted to accomplish that 3 times, we would have to write 30 lines of code. Just repeat each 10 lines 3 times. But if we had a function to do it, then each time we want to repeat the task, it's only a single line. So it helps clean up our code and prevent code duplication. And it also is useful for abstracting away code. And what that really means is a lot of times there's things that we don't want to do, we don't care about, or other programmers don't want to have to worry about. And it's better if they're predefined or someone else, abstracts the code away. So for example, something like print. If you had to write the print function every single time you wanted to, or in every program, that would be a lot of work. You would have to figure out how to connect Python to the standard output, how to actually print something to the terminal. It's not that hard, but it's not something that you usually need to worry about. It's been abstracted away. Similarly, things like generating a random number. While we could write our own code to do that, it just makes sense for that to have been done by someone else. It's kind of abstracted away. We don't have to worry about it. And we could do the same thing if we were building our own tools, our own framework for other Python developers to use. There might be a function or two that we give other developers for free that they're able to use and that we've abstracted away. And lastly, another reason I think that's worth discussing is that functions can help you not only reduce duplication in your code, but organize it logically, make it clear what's happening where. So here is the rock, paper, scissors game that I've refactored using a couple functions. If you didn't see the rock, paper, scissors sections, don't worry about it. It shouldn't make that much of a difference. But before, it was just a jumble of code, what people would call spaghetti code, all over the place. But with functions now, things are separated into discrete tasks. So we have some code that displays a header. We have some other code that picks a computer move. We have code that calculates winner. We have code that starts a game, that displays the winner, and it's clear, what each bit of code does. Rather than just having it be all willy-nilly all over the place, functions allow us to organize things.